All right, guys. So what is this business and SAS? What is going on? So these are, let's back up. Yesterday we talked about how two triangles can be congruent. So let me just get my triangles that I made here. Oh, did I take, oh no, there they are. Or no, maybe, did I take them apart already? Oh shoot. Hang on, I gotta make new triangles. I thought I had them. Here we go. Okay. Put these back in the bag. Sorry, I thought I left them together. Ooh. Okay, so yesterday we talked about having two triangles that are congruent, means that they have to have the exact same shape and the exact same size. So I have to be able to take one triangle and find a way to line it up so that they match perfectly. Then I know I have congruent triangles. So I have to be able to turn it or flip it or flop it or whatever so that they match up perfectly. So, but that's a lot of information to be checking. All three sides and all three angles, that's a lot, okay? That's a lot to check. So lucky for us, there are some shortcuts where there's only 3 things I can check. And the other 3 pieces just fall into place automatically. So the first one is something called side-side-side congruency, or SSS, right? So let's zoom in a little bit. I'm going to talk to you about it in words, and then I'm going to show you with my cool snap together triangles how this works. Okay, so SSS stands for side-side-side congruency. So here's what this is claiming, and I'm going to prove it to you in a minute. If 2 triangles are made from the same 3 length sides, the triangles must be congruent. So in plain English, what this is saying is if I said to you, hey, draw me a triangle where the 3 side lengths are 3 inches, 4 inches, and 5 inches. And then I said to your neighbor, hey, draw me a triangle where the 3 side lengths are 3 inches, 4 inches, and 5 inches. You're both going to draw me the exact same triangle, as long as you followed my directions, right? If you really had a triangle of side lengths 3, 4, 5, and your neighbor had a triangle of 3, 4, 5, they are automatically congruent. Notice I didn't see anything about the angles. I didn't tell you that what the angles had to be. So what's going to happen is, let's imagine that my first triangle here is the one that you drew with side lengths 3, 4, 5. Okay, let's just pretend. Then here's your neighbor's paper. They did the same thing, 3, 4, 5. They drew their triangle like that. Okay, if I took your neighbor's triangle, cut it out of their paper, and I walked over to your paper, I'd be able to flip their paper over and line it up. And look at that, the angles automatically match. We didn't whip out a protractor. I didn't say anything about you got to make this angle this many degrees, that one that many degrees. They automatically will match. That's so cool. That's because there's only one configuration for a triangle of side lengths 3, 4, and 5. That's the only triangle you could make. The only thing you could do is like draw it differently, like flopped over or upside down or whatever, but it is still the same triangle. That's so cool. So it doesn't matter who in the world draws the 3, 4, 5 triangle. as long as they do it correctly, everybody will draw the same exact one. The three angles will match magically, because there's no other way a 3, 4, 5 triangle could fit together other than having the angles as they are here. That's so neat. So what that tells me is if I have a triangle, two triangles, where I know the three sides match up, they're automatically going to be congruent. I don't even have to look at the angles anymore. So let's draw this on our paper here. Okay, so if you have a triangle, it doesn't really even matter what it looks like. Let's call this triangle ABC. And let's have triangles DEF over here. If I know that the three sides here match up with the three sides here, I'm golden. So let's say that AB matches with EF, AC matches with DF, and BC matches with ED. If I have that, if I know three sides match with three sides, I don't even need to check the angles at all. They are automatically congruent. So I can now come in and say triangle ABC is congruent to triangle. If I say ABC, how do you have to name this other one? Oh, actually, this is a great question. I kind of talked about this yesterday. What do? I didn't mark any of the angles because I actually don't care about the angles here. So how do I know which angles match up if none of them are marked? I did tell you something yesterday that you could look for. Sometimes it's obvious, right? Sometimes I can clearly see which angles match up, but sometimes the triangles are really kind of close in shape and I can't tell, right? Like if it's really close to being an equilateral triangle, I can't tell what angle matches with which angle. So does anybody remember what I told you you could do? So for example, who's going to match up with angle A in the other triangle?
D.
Not this time.
Oh, wait, no, F. Sorry, F.
F. And here's how you check if they're not marked. If their angles are marked, then it's easy. Then I'm just looking, okay, who's got one arc? Who's got one arc? Who's got two arcs? Who's got two arcs? Here, nobody's marked, right? The angles aren't marked at all. So here's how I can check if it's not immediately obvious who matches up. Angle A, look at the two sides that make up angle A. These two sides come together to make point A. You look at how they are marked, the sides. So I have one slash here and two slashes here. So when I come over here, I got to look, okay, so here's the sides, one slash and two slashes, where they come together, that's point F. So that's how I know for a fact that F is the one that matches up with A. And then I do the same thing for B. B is made by one slash and three slashes. So who over here is where one slash and three slashes meet? Let's make that darker. What letter's got to come next?
E.
Yes, it's got to be E. So then obviously C has got to match up with D. Okay, so we can now say that those two triangles are congruent by side, side, side. All right, so what we're basically going to be looking at today is I'm going to give you a ton of triangles, pairs, and I'm going to ask you if they're congruent or not. And if they are, you need to tell me by which of the, we're learning 2 ways today. There's 5 altogether. So we're going to learn 2 today and 3 more tomorrow. So I'm looking, if I have all 3 sides marked the same, that means those triangles are going to be congruent by side, side, side. Okay, let's get to our second way. The second way is SAS, SAS, but not really SAS. It stands for side angle side. So here's the deal with this one, side angle side. I need to have 2 sides that I know are the same, okay? And the last one, I had to have all 3 sides the same. Now I only have to have 2. okay? But the difference is now I need an angle in between them. So now I do care about one of the angles. So let's see. Let's write this in words. If two sides in two triangles are congruent, and so you have to have this as well, and the angle between them, there is actually a vocab word for that angle, the angle that's between them. So I'll put that here. The included angle. So if you ever hear that phrase, included angle, that's what they're talking about, the angle in between two sides. All right, so if two sides in a triangle are congruent and the angle between them, the included angle, is also congruent, then the triangles are congruent. All right, let me give you a minute to jot this down, and then I will explain in plain English what is happening here. Okay, so let me explain how this works. So this is like me telling you, all right, let's assume your name is Susie. Susie, I want you to draw me a triangle. And here's what I want. I want one side to be 3 inches, one side to be 4 inches. I don't care about what the third side is. Irrelevant. I don't care. Make one side 3 inches, one side 4 inches. Now, the angle where those two sides meet, make that 60 degrees. Okay? So I tell Susie all those directions. She comes up with this so far. Let me zoom in a bit. So she's got one side 3 inches, one side 4 inches. And I don't know if you can see it, but she has made a 60-degree angle between those two sides. Okay, so obviously she needs to finish this triangle, so she would need to just connect these two, but she's not measuring that side. She's just going to connect those dots and see what comes out, right? So I don't care about what the third side length is. I care that this one's green. I care that this one's yellow because that's 3 inches and 4 inches, and you made a 60-degree angle in between them. Okay, so whatever the third side ends up being is what the third side ends up being. So there we go. So she has created that triangle now. So I give the same instructions to Susie's neighbor. I say, hey, Susie's neighbor, you do the same thing. Make me a triangle that's 3 inches on one side, 4 inches on another, and just make sure there's a 60-degree angle in between them. So let me line that up a little bit better. There we go. So there's Susie's neighbor. She does the same thing. She makes a 3 inch or 4 inch. We don't care about the third side. I say, you don't even have to measure the third side. I don't care what it is. I don't care what the other angles are. Obviously, you're going to have to connect the dots to finish the triangle. So they come and they connect the dots. Well, lo and behold, what happens? Now I go ahead and I say, okay, Susie, you give me your triangle. Neighbor, give me your triangle. Look at that. They are exactly the same. So even without, I don't even care what this third side is. It doesn't matter. If these two, if this side and this side match, and then the bottom side and the bottom side match, and the angle where they meet is the same. That's what we call side angle side congruency. So as long as you follow my directions, everybody again would make the same exact triangle. If you made one side 3 inches, one side 4 inches, and the angle in between them 60, all the other pieces have to fall into play to create that triangle. This third side will just happen to end up being the same length on everybody's triangle. These other 2 angles are automatically going to be the same. That's so cool. So with only 3 bits of information, the other 3 just there's no other configuration. Because think about it. If I tried to make that angle anything else, right? So if I made that angle 70 degrees, now that third side is going to be different. So if I want that angle and I want those 2 sides, there is one and only one configuration of triangle that's going to work. And that's why everybody in the whole world would have the same exact triangle if they followed those directions. So cool. I know, right? That's crazy. So let's draw this as a picture. So if I had this triangle and I had this triangle, oops, that's not a good one. Okay, so here's what I know this time. I'm going to say I know that those sides are the same, and then I know maybe this bottom side is the same. And I know the angle in between them is going to match, whatever it is. So where those 2 angles match. If you have this, you will automatically, this third side will automatically be the same. This top angle will automatically be the same. This little angle will be the same. I don't even have to measure them. It's so cool. So this is side angle side. So what's so important about this is that it has to be the angle in between the 2 sides. So with the 2 sides that are marked to meet, it has to be that angle. That's what I'm talking about when I say included angle. It's the one included in between the 2 sides there. Okay, so let's throw up a congruency statement for these. If this is ABC and this is DEF. Now let's see who matches. Triangle ABC is congruent to triangle. This time I do have one of the angles marked. So angle A matches with who?
F.
F. So we got one kind of for free. And then let's see, B. So look at B. B is formed by 1 slash and then no slashes. So I look over here, who's 1 slash and no slash? Oh, it's got to be E. So E, and then it's got to be D at the end. Okay, so all I want to do now is give you a bunch of triangle pairs, and we'll see if they are, oh yeah, so this is by side angle side. All right, so I want to decide if I have enough information to say that these 2 triangles are congruent or not. And if I do, then by which way? Is it using side, 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 or is it using side angle side? All right, so let's take a look. I gotta turn the page. So hopefully you got this. Are the triangles congruent? If yes, then how? So that's really what I'm trying to find out here. And let's take a look. So I'm just going to draw you a couple of random triangles. Okay, so let's talk our way through these real quick. So if I look at the first one, sometimes it's easy to just sort of, I don't know, go through it kind of like, what am I trying to, process of elimination. So I always like to start with side, side, side. Do I know that all three sides in both of these triangles are the same? Are all three sides marked?
Wait, what was the question? You cut out.
Oh, sorry. Do I know that all three sides in this triangle match all three sides? In other words, are all three sides marked congruent?
Yes. No.
No, two of them are. I have this one marked with 1 slash, this one marked with 2 slashes, but I don't know that this third side is the same, right? There's no markings there, so I don't know if it's the same length or not. Maybe it is, maybe it isn't. So I cannot go with side, side, side. That's out the window. So then I look, okay, well, could this be side angle side? I do have two sides. Do I know for a fact that the angle where those two sides meet is equal?
Yes.
Yes, they're both marked 90, and two 90-degree angles are certainly the same. So yes, these two triangles are congruent by side angle side. So I guess I should have said yes by side angle side. Because the question is, are they congruent? Yes, they are, side angle side. Oh, I just realized I got to give you another one. Okay, let's try the second one. Here's the second one. Now, if you remember from yesterday, remember what happens when we have a side that they share? What did we do yesterday? Does anybody remember? That was that bit I talked about, the reflexive property. All right, so this is super important. So make sure everybody's listening. If two triangles share a side between them, it's automatically congruent to itself. We spoke on this yesterday. The reflexive property, that's what tells me, hey, this side is, of course, it's equal to itself. So now you can look at this and say, okay, well, are these congruent by side, side, side? Do I know that all three sides in one triangle are equal to all three sides in the other?
Yes.
Yes, all three sides are marked. I am allowed to come in and mark. There's two things I'm allowed to mark. I am allowed to mark shared sides congruent to themselves. And the other thing I'm allowed to mark, you're going to see in the next problem. What was that? I heard something, but I couldn't make out what it was. Uh-oh, am I cutting out? Shoot. Let me join on my, I'm going to turn on my hotspot real quick if you can hear me. Can you? Can you hear me?
Yeah, we're good.
Yeah.
Oh, you can? All right. Looks like my camera just cut out though. Let me just reset this camera quick. Or is the camera still going on your side? Oh, wait, there we go. Never mind. Switch. That I'm like moving. Oh, there we go. I got it. All right. And you can hear me?
Yeah.
All right. So this one was yes by side, side, side. So you get to mark if any two triangles share a side, it's automatically congruent to itself. The other thing you get to mark is right here in number 3. Right now, see how I have 2 sides marked the same? That side's the same and this side's the same. They don't share a side like a wall like in the other one. But what does this diagram have that I know is always going to be equal?
Well, I wouldn't say because it's vertical, because
Yes, that's exactly right. Vertical angles are always equal. So that's the other thing that you get to add to a diagram. There's not many things that you get to add on. You get to add on if they share a side between them, like they did in the last problem, you get to mark it congruent to itself. And if you have a pair of vertical angles, you get to add it in. So these 2 triangles now, yeah, I have 2 sides in each that's marked, and it's the side where they both meet. And you got to make sure that it's marked the same in both triangles. And they are. So, yep, I've got an angle in between the 2 sides, an angle in between the 2 sides. So this one's going to be a yes by side angle side. Okay, so you take a look at this one. You have 2 sides marked already. Is there anything else that you get to add to this diagram? And if there is it enough to say that they're congruent by one of the 2 ways, side, 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 or side angle side?
yes.
Yes, they share this side between them. So I get to mark it congruent to itself. And now I have enough to say by which method? Side, 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 or side angle side?
Side angle side?
Which,
no, side, side, side.
yeah, side, side, side. Because I don't know that any of the angles are the same, right? None of the angles are marked, and I don't have any vertical angles. So even though some of the angles look like they might be the same, I don't know that. But I do know that the 3 sides are the same. So this is going to be a yes by side, side, side. All right, one last one. Let's take a look-see-loo here. I'm trying to trick you on this one. I'm just trying to, that line was stray line there. Okay, so look at these 2. It certainly can't be side, 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 because I don't have all 3 sides marked the same. And so side, side, side is out. Maybe it's side angle side. I don't know. What do you think? Do you think it's 2 sides marked the same and the angle between them?
Yes.
I beg to differ. The angle between them, right? Think where these 2 sides meet would be right here. It'd have to be this angle that's marked the same to be side angle side.
Right.
And this one's not. This actually spells a bad word. You have an angle, and then you have a side, and then you have a side. That, if it spells the bad word, that means it is never the right answer. Never. Or the bad word's backwards. So if it was side, side angle, that never works. Okay, we'll talk more tomorrow about why that doesn't work. But this is not side, 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 and it is not side angle side. You have to have the angle in between the 2 sides, and this doesn't. So this is, they are not congruent. Or at least I can't prove that they are. It may just so happen that they are, but there's no way that I can prove it. So I'm not putting my name on that. Okay, so
Right.
Does this make some sense?
Yes.
Okay, so I am going to, your homework, I think again is on CUDA. I think this whole chapter is on CUDA, I'm pretty sure. So let me, it's pretty straightforward. It's just like we were just practicing here. Let me just find it. Homework 5.5. Here we go. Where's our B block? Okay, so if you hop onto CUDA, you will see this. I will do a couple of them with you, but they should be pretty straightforward. Let's see. I'll just share this with you. Okay, so real quick, you're going to pop on. You're going to have two triangles that are going to be marked. And in this case, yeah, all three sides are marked the same as all three sides. So that one's just going to be side, side, side. So, yep, that was easy. This one. Now, I come in and I say, oh, hold on. In this diagram, isn't there something that I can do here? This, what the heck? Why am I not seeing the shared? Do you guys see the shared screen? The problem?
Yeah.
Oh, I don't see it on my iPad. Oh, switch to screen share. That's so weird. Never seen that before. Any hoosers, you get to this diagram and you're like, oh, wait a minute. She told me that there's something that I can do. I get to draw in the vertical angles for free. Anytime you have vertical angles, they're always congruent. So now you look and you're like, oh, I have two sides and the angle between them. That is side angle side all day long. So be careful. At first glance, you may think that there's nothing, but make sure that anything that you can mark in the diagram, you are. So let's see. Oh, here's one. I see all three angles are the same as all three angles. But that's, you only have two options today. Side, 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 or side angle side. Do you know? So there's like B, we don't even know what that is yet. So obviously that's not the right answer. If you don't know any sides are the same, could those triangles be congruent? I shouldn't say that. Do you know that they're congruent? No, you don't. So you're going with choice D on that one. I don't have enough information. I only have two choices today, side, 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 or side angle side. If it's not one of those two, I'm going with no, I can't do it. Oh, there's one. They have that shared side. So remember, you get to come in and mark it the same. So now I see, oh, yep, I've got side, side, side. I have all three. Cool. Here, I have two angles in the side. So it's up to me to determine, okay, well, is it the angle in between those two sides? So is it really side angle side? What do you think? Is this actually side angle side or is it not?
No. Maybe. Possibly. Yes.
It is. See the two sides that are marked? And see where they meet? If it's the angle where they meet that's marked, then it's side angle side. So that one's going to be a yes, side angle side. So this one, I have two sides. I don't have a third side, so I can't go with side, side, side. Can't do that. And I don't have any angles. So I can't do this one. Yeah, this one's a none. I don't get like vertical angles that I get to draw in for free. Nothing like that. So, Haley, you tell me this one.
Side angle side?
Yes, because you have the angle in between the two sides that are marked. So that is classic side angle side. Correct. Ooh, this one's tricky, but I'll help you. So they share a side between them, don't they? So I get to mark that side. And here's what I would recommend doing. When you have a triangle like this, I wish I had a piece of paper that I could just cover, but just ignore one of the two triangles. Let's just look at just that triangle right there. Don't I have the angle marked in between the two sides? I do. So that top one is marked for side angle side. Let's just make sure that the bottom matches it. So let's see. So now if I only looked at the bottom triangle, so let me cover this up. Yeah, that one's marked the same way. That one has the angle in between the two sides. Where the two sides that are marked meet, that's the angle that's marked. So that is side angle side. So yeah, side angle side for this one. Okay. This one real quick, they share this side, so that one should just be side, side, side. right? All three sides, all three sides. If they share that side, I get to mark it. I'll do one more with you, and then I literally will have done half of your homework for you. Oh, this is a great one. Oh, I'm so glad that this one came up, because this one's a trick question. Are you looking? Look at it. At
Yeah.
first glance, you look at this one, and you're like, oh, that's side angle side, right? You're right. That one is, but this one, look at the second triangle. This is not marked side angle side. This angle is not the one in between the two sides that are marked, right? Where the two sides that are marked meet, it has to be that angle. So if it was this angle that was marked, it would be side angle side, but it's not. So since the two triangles have to match each other, and they don't here. So this one is actually C. Ooh, tricky, tricky. All right, class is over. I hope that you find the remaining 10 not that bad. Okay, guys, I will see you tomorrow.
Bye.
Bye.